Example 9. We want to convert an area unit. This isn't just plain inches, this is inches squared, and so that adds an extra little bit of complication to the problem. So instead of writing inches squared, we're going to write the inches as separate units multiplied together. Then we're going to multiply by a ratio to change the inches to centimeters. But notice that only one unit of inches on the top and one on the bottom will cancel out in this case. And so we multiply by another ratio that's exactly the same. And now that will cause the other inches to cancel out. Now we type that into our calculator and we get our answer of 19.4. So in example 10, again, we're going to write our feet squared as separate units multiplied together. And we're going to multiply by a ratio to change the feet to yards. And we have to do that twice. And then another, the units cancel out. And then another set of ratios in order to convert the yards to meters. Now remember, when you type this into your calculator to use your order of operations, use your parentheses, I would type it in as 3 divided by 3 divided by 3 times 0.914 times 0.914. So all of our units cancel out and we get 0.278. For temperatures, we don't do it with ratios. We have to use this equation. So you put in the 50 for the F, do your parentheses first, and then multiply by 5/9. And we get our answer of 10 degrees Celsius. In this case, we are given Celsius, we want to find out Fahrenheit. I'm going to use the exact same equation as before and solve for the F. Now there is a version of this equation where the F is by itself over on the left-hand side, but I'm not going to show that because then you have two equations that you have to remember when only one equation will really be fine. So anyway, we put in the -40 for the C on the left-hand side, and we want to solve for the F. So the first step is to get rid of that 5/9. And then we add 32 to both sides. So notice that the temperature in Fahrenheit is the exact same number as the temperature in Celsius. This only happens once, and it's at the -40. Okay, now in this problem, we start off with Fahrenheit, and we want to get kelvins. Remember, kelvins is the temperature scale where 0 is the coldest temperature possible. And the size of the degrees in Kelvin is the exact same as the size in Celsius. I shouldn't have said degrees in Kelvin. Kelvin, you don't say degrees, you just say a certain number and then the word Kelvin. Anyway, here we go. So we put in 2000 for Fahrenheit, subtract off 32 from 2000, and multiply by 5/9, and we get 1093. Now that's Celsius. Now to convert to Kelvin, we use this equation. C equals K plus 273. Put in the 1093 for the Celsius, and then subtract off 273, and you get 820. Now in chemistry class, you may have seen a method of converting where you have this bracket, sort of like a tic-tac-toe thing. And you put in your original number up here, and then your ratios of equal measures there and there. And then you do your calculations. So think back about how you did that, and compare my method with this chemistry method. How are they the same? How are they different? Which way do you like better?